Hello everyone. We are looking at phase 3 chapter complex number exercise 1. We are at question number 15. Okay, let's look at the question. The question is prove that there exists no complex number z such that mod z is less than 1 by 3 and a sigma or a summation is given to us. All right, so these few questions as you would have seen in the package, the few questions that we have just now discussed and maybe some more, they are all very conceptual question, I would say, and good question. They will give us in-depth understanding of complex number and a lot of confidence also how to go about it. Let's look at this question. So prove, okay, a little bit of correction. This summation is going from R to 1. So let's write what is the meaning of the summation. A z plus a2 z square plus a3 z cube and so on, and an zn is equal to 1. Okay, and where mod a or the coefficients, they are always less than 2. All right, they are always less than 2, and we have to show that the mod of z is also less than 1 by 3. Also less than. Okay, so I think because the mods are involved, so first thing always we can start with taking mod both sides. So the moment we take mod both sides, we know the value of this is equal to 1 because mod 1 is 1. After that, we have to, I think, we know the way forward is we have to induce triangle inequality. So we know that the value of this is always going to be less than equal to the individual modulus. That is az plus a2z square plus a3z cube and so on, an zn whole mod. Now we know the mod property. When two complex numbers or two numbers are multiplied, then mod can break down into individual components. So that will basically give us something like this. A2z square, and we know that square mod of square number is also mod can come out from the modulus. Square can come out, something like this. If you want to take, this is some same as this. So this property of mod, very useful here. So plus a cube, z cube plus and so on, and an z to the power n. All right, so what are we looking at? We are looking at an expression. However, we have been told, sorry, if I just put the mod here. So we have been told in the question that the value of 2a3, like I think it is a1 we can write safely. Yeah, a1. So a1, a2, a3, the mod of this is always less than 2. Okay. So for convenience or for the simplicity of this question, for the sake of solving the question, if this whole quantity is more than 1, if I set it to a higher value, let's say 2, then obviously the inequality is not going to be disturbed. We are still in the inequality. So what I'm trying to say is, let us put this, all of this. I am putting all of this as the limiting value, 2. It is always less than 2, but I am putting it as 2, the limiting value. So how it is going to help me? We are going to factor out 2 from here, and then we are going to be left with z and square and cube and powers of z. And we know what to do with it. We know what to do with it. It's a GP where the common ratio is z. And because in the beginning, we've been told that z is less than 1, so we can take the other alternative formula. So 2 into z, 1 minus z to the power n, 1 minus z. Because we cannot start with the contradiction that z is more than 1 and switch the formula. So this is, now if we just cross multiply, 1 minus z is equal to 2z minus 2 into z to the power n plus 1. N plus 1. Now this z can Okay, I'm sorry. This Z, because it is a positive number, it can easily come here. So what do we get? Rearranging everything from here. So 3Z is greater than equal to 1 plus 2 Z to the power n plus 1 dividing by 3 throughout. So Z is greater than 1 by 3 plus 2 by 3 and Z n plus 1. So what do we do? We come to the conclusion that mod Z is 1 by 3 plus some number. Whereas in the question it is given to us, it is less than 1. So it's a contradiction. For this relationship to be satisfied, Z has to be more than, the mod Z has to be more than 3. So no such Z is possible. Because mod is 1 by 3 is less and then still satisfying this condition. All right. Thank you.